So now we're going to talk about formula weight, molecular weight, and molar mass. We're going to start out by talking about the only difference between the three. So if you see here, the only difference between formula weight, molecular weight, and molar mass are the units. That is the only thing that is different among them. They all have different units. So what I want you to notice is the formula weight and molecular weight have the term weight in them, and molar mass has the term mass, and that's going to help you remember the units, because the formula weight and the molecular weight both have the word weight, and they both use the unit AMU. Remember, AMU stands for atomic mass unit, and molar mass uses the unit grams per mole. They are calculated exactly the same way. The only difference is you put different units on them depending on what the problem is asking for. So the way you calculate either formula weight, molecular weight, or molar mass is you take all of the elements that exist in the compound and you multiply by any subscript. So first we have to fix this real quick. This formula, go ahead and fix it on your worksheet, should be KMN04. So we were missing a little bit of an N there. So go ahead and fix that. So this is the way you figured it out. Okay, you say, what elements do I have? I have a K for potassium. I have Mn for manganese. And then I have an O for oxygen, but make note that there's a 4 there. The subscript of 4 is on the oxygen. That's going to be important. So what you do to calculate the formula weight is you look up each of the atomic masses from the periodic table of each of these elements. So when I use the periodic table, I'm going to find potassium is 39.10. Manganese is 54.94. And oxygen is 16. And again, I found those right on the bottom of the periodic table squares. What's important though is this oxygen has a subscript of 4. That means there are 4 oxygens there, which means you have to multiply the 16 by 4 in order to show that there are 4 of them. Each oxygen has a mass of 16. So when there are 4 of them, you have to multiply by the subscript. Then you simply add them all together, and you get a total of 158.04, round to 2 decimal places. And then the unit, again, comes from what it is. This is formula weight, which tells me my unit is AMU. So that is my answer, 158.04 AMU. The way I calculate it is not going to change. So when I do the next one, when I start number 2, I'm going to have a calcium. So I'm going to identify the elements. I have a nitrogen, and I have an oxygen. Now what I want you to pay attention to is this 2 outside of the parentheses. Just like in math, when something is outside of the parentheses, it distributes and multiplies through. So in this case, you have 2 nitrogens because that 2 gets multiplied by the 1 that's there. And then you have 6 oxygens because you started with 3 and you multiply that by the subscript of 2. So again, I'm going to look up their atomic masses on the periodic table. So calcium is 40.08. Find that right on the periodic table. Nitrogen is 14.01. I'm going to multiply that by 2 because the subscript of 2 is there. Oxygen again is 16, and this time I'm going to multiply that by 6 because it starts with a subscript of 3, and then you multiply that by 2. And then again, I'm going to multiply through, add them all together. I get a total of 164.1. In this case, it's asking for the molecular weight, which tells me my unit is AMU. And then for the final one, again, nothing changes with the math I'm doing. I identify the elements present. So I have Na, I have S, and I have O. The Na has a subscript of 2. S just has a subscript of 1. Remember, there's nothing written there. The subscript's 1. And then O has a subscript of 4. I look up their atomic masses on the periodic table. Na is 22.99. You could leave that as 23 if you wanted. You multiply that by 2 by the subscript. S is 32.07. Oxygen again, one more time, is 16. This time I'm multiplying that by the subscript of 4. Multiply through, add them all together, and I get 142.05. There's my answer. In this case, it's asking for molar mass. Again, weight in number 1, weight in number 2. They both had a unit of AMU. This time it says mass, so your unit is going to be grams per mole. So again, they are calculated exactly the same. The only difference is the unit that you put on the end.